Alip mula duluan
Okay.
Alip lah.
Aku dah dah start.
Kau start recording kat sini
Alif dah record.
Dia rekod sini
Yang
aku
Islam.
rekod.
Hai, Assalamualaikum. Nama saya Muhammad Afiq Azri bin Sulaiman, 11 DKM 19F1022. Next.
Assalamualaikum. Saya Muhammad Azli bin Hamdan, kelas DKM 3B, 11 DKM 19F1031. Next.
Mutu.
Assalamualaikum.
Saya
Saya
Muhammad
Arif.
Alif Azmi bin Azmi. Nama matrik saya 11 DKS 19F1052.
Okay, saya kelas kali saya Arif Zafran bin Osman, 11 DKM 19F1058.
Kita orang nak bincangkan tentang lab. Alip, share screen Lip.
Okay, Alif, let's go.
Let's go.
Nampak
Nampak.
Hadir.
Okay, saya terangkan tentang tajuk je tensile testing on mild steel. So, objective virtual lab to study the mechanical properties of mild steel specimen under tension load. 3.0 ni ada procedure, ni adalah contoh step je kat virtual lab. Dia ada 10 step. Dan ni adalah data collection yang telah kita buat pada virtual lab. Ini adalah graf bacaan dia. Contoh load versus every scale reading dengan load versus extensometer reading. Next, 5.0 analysis and calculation. Ini adalah contoh calculation yang saya buat dapat daripada virtual lab. Ni telah sediakan formula. Kita terus kat soalan je. Draw the stress strain diagram for a ductile and brittle material and what is the difference is it? Yang first, typical ductile material. Ductile material are tubes which can be drawn into wires when tension is applied and can be drawn into sheet when compressive load is applied. For the above mentioned properties, the material should have a tendency to elongate. Example dia, for lower value of stress, the strain produced is much higher. So from point B to D, the region is called elastic region. As material have to be elastic to possess the property of ductility and so-called material. For the brittle material are those which can elongate as much the ductile materials because they don't have such a long region. Point B and some materials even don't have point D. They just have fracture point after point B, or they have higher value of stress or a little value of strain. So what do you understand by strain hardening? Strain hardening is generally defined as heating at a relatively low temperature after cold working. During strain hardening, the strength of the metal is increased and ductility decreased. Number 3, what do you mean by percentage reduction in area? Percent reduction of area is a ratio that expresses how much the specimen narrow when compared to its original size. It is calculated by dividing the difference between the original value cross-sectional areas at the point valued by the original cross-sectional area of the test specimen. But explain the step in the ductile fracture. The basic step in ductile fracture are void formation. Void also known as the crack formation, crack propagation and failure, often resulting in a cup and cone shape failure surface. Voids typically present around precipitate secondary phases, erosion and at grain boundaries in the material. Number 5, explain the mode of failure intention test. Fracture when cracks appear. Number 2, you give when a body experience stress. Number 3, coupling when a loss of stability creates big damage. Number 4, fatigue when time causes a loss of strength. Number 5, creep when a body develops over time. Yang last, conclusion, failure of certain material under tensile loading can be attributed to crack and fracture. This form of subtle fracture occurs in states that initiate after necking. First, small microvoid form in the interior of the material. Next, the formation continue and the microvoid enlarge to form cracks. Finally, the crack propagation is rapid along the surface that makes about 45 degree angle with tensile stress exists. The new structure surface as an encourages the final sharing of specimen produce a cup-type shape on the fracture surface, cone-type shape on adjacent fracture surface. In this center instance, has an angular and vectors appearance which signifies plastic information in material. Itu saja. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Azli Biamsan di kelas 3M DKM 3B 11 DKM 19F 1031 bersama dengan Arif Zafran, Muhammad Afiq Azli dan Muhammad Alif. Dan saya mau membicarakan tentang lab 2 iaitu bending test on mill steel. Ini nombor 2 visual lab tajuk bending test on mill steel, dan 2.0 iaitu objective visual lab to study the behavior of mill steel rod subject to a gradual increasing equal load at 1 per span and to determine mechanical properties. And 3.0 is my simulator step. It's 1, 2, 3, 4, 5 and step 5 is have data. 6, 7 and 7 have graph, seems like step 8. And 4.0 is my data collection, first data, first graph and second graph. And this is my discussion. 5.0, what is bending stress? The stress is in a material just before yield in a fracture test. Second, I don't have answer. And 3, which is the IS code used for bend test on steel. IS 5242 1979. 4. What is the equation governing simple bending, known as flexure equation or equation for theory of simple bending? 5. How is the failure of ductile and brittle material under bending load? A ductile material is usually considered to have failed when it suffers an elastic failure. Brittle material fail by shear when compressive stress attain the maximum value. And 6.0 is my conclusion. Bending stress is defined as a material ability to resist deformation under load. It represents the highest stress experienced within the material at this moment of rupture. These are 2 types of bending test: 3-point bending test and 4-point bending test. In a 3-point bending test, the area of uniform stress is quite small and concentrated under the center loading point. In a 4-point bending test, the area of uniform stress exists between the inner span loading point, typically half the outer span length. And 7.0 is my reference. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hai, nama saya Muhammad Afiq Azri bin Sulaiman, 11 DKM 19F1022. Hari ini saya akan menerangkan pasal lab 3 virtual lab. Tajuk lab ni deflection of the beam. Objektif dia establish the relationship between deflection and applied load. Okay, seterusnya determine the elastic modulus of the beam specimen from the deflection data. Okay, ni prosedur dia. Step 1, put the support beam on the table, install the support to the support frame, measure the distance between two support is 1 meter. For measure the width of the specimen by using vernier caliper. Take the data. Measure the depth of specimen by using vernier caliper. Take the data. Place the beam specimen on the support. Put the rider on load hanger in the mid-span of the beam. Fix the load hanger at the rider of load hanger. Position the dial gauge at the support frame. Turn 0 to dial gauge. Put the 2 Newton load on the load hanger. Take the reading of dial gauge black needle. Add 2 load on the load hanger. Take the reading of dial gauge. Add 2 more 2 Newton load on the load hanger. Take the reading. Add more 2 load Newton on the load hanger. Okay, here's the data. Ni data dia, paste here. Okay, ni datanya. Ni calculation dia. Okay, ni calculation lagi. Okay, conclusion dia. The deflection is measured from the original nature surface of the beam to the nature surface of the deformed beam. The configuration assumed by the deformed nature surface is known as the elastic curve of the beam. Deflection of the beam. Deflection is defined as the virtual displacement of a point on a loaded beam. Okay, terima kasih.
Okay guys, Assalamualaikum. Okay, saya berkumpulan dengan Alif Najmi, Afiq Azri dan Muhammad Yazli. Dan nama saya Arif Zafran bin Osman, 11DKM19F1058. Hari ini saya nak membincangkan tentang lab number 4. Okay, tajuk lab ni torsion test on my steel. So the objective of the test is to study the mechanical property of my steel under torsion. Okay, sekarang kita tengok simulator step. Step number 1, measure the initial diameter of the torsion test sample at 2 or 3 places and the average value is obtained. Okay, step number 2, the gauge length of the beam is restricted at 180 mm. Step 3, now the specimen is chalked out on the gauge length for understanding the effect of torsion. Step number 4, insert the specimen into its position within the torsional experimental setup. Step 5, start the motor and slowly apply the twisting load on the specimen. Okay, so step 6. Okay, so kita nampak data dia. Data dia dah bagi. So result data dia ni lah dia. Okay, calculation. Okay, ni calculation dia. Alamak. Okay, calculation dia. Okay, lepas tu sekarang kita baca discussion dia. What do you mean by modulus of rigidity? The modulus of rigidity, also known as shear modulus, is defined as the ratio of shear stress to shear strain of a structure member. This property depends on the material of the member. The more elastical the member, the higher of the modulus of rigidity. Number 2, define the modulus of rupture and ultimate strength pertaining to the failure of beam by flexion equal to the bending moment at rupture divided by the second modulus of the beam. I'm sorry, number 3, I don't understand because I don't know. Okay, we go to the straight number 4. Why does the brittle material fail in helicoidal shape in ductile material shears on right section under torsion load? And brittle materials are weaker in tension than in shear. From this, they concluded that when subjected to torsion, circular shaft made the ductile material breaks along a plane perpendicular to its longitudinal axis, and the brittle material break along surface forming angle 45 degree with the longitudinal axis. Number 5, what are the different failure mode of the specimen? Generally, 3 different types of failure were observed: shear, mix, and split. Finally, Griffith's theory was utilized to analyze the maximum tensile stress around the crack. The findings of this paper can also be used for practical engineering problems. Lastly, conclusion. In torsion testing, the circular bar is placed in the machine in such a way that its longitudinal axis coincides with the axis of the grips, and so that it remains straight during the test. Then rotate one grip at a reasonable constant speed until the test piece breaks. Here the shearing stresses will develop in any cross section of the bar whose values increases linearly from 0 at the center to a maximum at the outer periphery. Drop to meter is used to measure the twist to an accuracy of 1 minute. That's all. Thank you. Bye bye.